Buenos dias, clase. Yes. Okay, so guys, we are doing lines and angles part 2. Okay, guys. Okay, we're recording right now. Okay? Did you cover your mouth there, Mario? Yeah. All right, here we go. Guys, you've already written this in your notes, okay? And this is lines and angles part 2, okay? And this is basically incorporating the algebra component into what we know now about two parallel lines cut by a transversal, which we also need to get used to the fact that it's not always going to look like this. It's going to be rotated, it's going to be on an angle. You have to be able to identify it, and when we use the clues, okay, which is key to your success, okay, which is what? This little arrow here, which I don't know if you saw that, and that little arrow there, which tells you that these two lines are parallel, and here's your transversal, okay? So now, even though we're used to seeing it this way, we're going to take that and just rotate it, okay? And this is what we're looking at, but we have to be able to see, you know, what angles are we looking at? It says, what is the value of y? We need to figure out what is the value of this angle right here. So we know what I need you to start thinking to yourself out loud is that, okay, here's our two parallel lines cut by the transversal, and these two angles are on the same side, and they are inside the two parallel lines. So these two angles are same side interior angles, okay, which means that they are supplementary. That means that this angle plus this angle is 180 degrees. So 80 degrees is already accounted for here. 40 degrees is already accounted for here, which means how would we find the measure of angle y by process of elimination?
That will also
80 plus 40 is 120. So 180 minus 120 is 60. Okay, that, yes, it is that easy, okay? So let's go down to the next example that you wrote in your notes. Again, we're adding the geometry component to this. So here it is. Let's look at this example. So here we have, okay, this example where we have, once again, two, okay, talk about using the clues. Okay, let me just scroll down here for a second right here, and I'm going to discuss this and get it out of the way. Okay, clearly you can see, guys, that we have two parallel lines, cut M and N, cut by transversal T, okay, and we've got the box and the box. That basically tells you that both of these are 90-degree angles, okay? And that makes sense that they are congruent because they are corresponding, because they're in the same position, different parallel line. And if we said, you know, that this was, you know, 3x plus 5, how would we solve for x? Well, we'd say 3x plus 5 equals 90 and solve for x. That's part of using the clues. The box is a clue. Right? So let's go back down to our previous example here where we just were. And here we have, once again, two parallel lines cut by this transversal. And you have to look at the angles that are labeled, okay? It's this angle and this angle. And you should say to yourself, oh, these two angles are in the same position, different parallel line. Those are corresponding, so I know that those are equal to each other. So how would we set this up to solve for the variable? We would set them equal to each other. So 55 equals 3w minus 2. Okay, and then we just solve for w. So if you add 2 to both sides, you get 3w equals 57. Do you have a calculator? Great. So divide by 3 on both sides, w equals what? 19. Okay, now it's going to add, now that we know, and how do we check our work? All you have to do is plug 19 in here, and if we get 3 times 19 minus 2 is 55, and 55, we know we did it correctly. Okay, so with the algebra component that we're adding, okay, you know that because all of these angles are either supplementary, which means they add up to 180 degrees, or congruent, you set them equal to each other. So you're either going to add them together, set it equal to 180, or set them equal to each other to solve for the variable. Okay, let's do one last example. Okay, so let's look at number 4. Hold on. Tell me later. All right, here we go. I don't know why that has that. That's kind of annoying. Hold on. Let me fix it right now on the spot. Which is what I am known for doing sometimes. Okay, so guys, here we go. Very, very, very important. So as you can see in the question up here, okay, it says in the figure, okay, here, what are the values of x and y? What are the measures of the 4 angles? What are the measures of the 4 angles in the figure? Well, here's what we need to start doing, okay? When you're looking at a figure, notice we have our clue. What is that clue? Our clue is that these 2 line segments in the figure are parallel to each other. Okay, so this is a parallelogram. Well, no, it's a trapezoid. Okay, but guys, what I need you to get in the habit of doing, because with the assignment that you're going to have many shapes and figures. Okay, what you need to get in the habit of doing is when you see those 2 arrows and you know that there are 2 parallel lines, I need you to extend what you see. So this is what I mean by that. You have to extend.
Oh my gosh.
Okay, do that. Okay, we're recording. Okay, and then extend the bottom. Okay, I need you to see that even though this is one side of the figure and one side of the figure, I need you to also see them as lines that go, parallel lines that go on to forever, okay? And then you have to see this side, okay, as a transversal. Look at that, you guys. So I know that's not perfect, but you get the idea. It's the best I can do. So now that you see, we've darkened it in, even though this was a trapezoid first, okay? Now we have 2 parallel lines cut by a transversal, and we can look at this angle and this angle, right? Because as you can see, we have the variable x and the variable x on this side. So it says in the figure, what are the values of x and y? Well, now that we have 2 parallel lines cut by this transversal, what kind of angles are these? They are on the same side and they're inside the 2 parallel lines. So these are same side interior. Yes, so those are supplementary, right? So we have to add these together and set it equal to 180. So 2x plus 1x is 3x minus 12 equals 180, right? You're writing as I'm writing. Then we add 12. 3x equals 192. And then divide by 3 on both sides. X equals, what's 192 divided by 3?
64.
64?
Yeah.
Okay, 64. So how do we find out the measure of these angles? Well, we just take it, right, and plug it in. So 2 times 64 is what? 128?
Yeah.
Okay, so this angle is 128. So if they're supplementary, how do we find the measure of this angle? 180 minus 128, or you can just plug in 64 here, and that would be 52. Okay? So now we're going to do the same. Watch what happens here. Okay? I'm going to do it in a different color. I'll do it in black. Okay? This line should also be extended, and draw the line and draw the line. You should also think of that line as a transversal now. So we have our two parallel lines cut by that transversal. So we're dealing with this angle here and this angle here. So we know that these are same side interior angles, okay? So we know this plus this equals 180 degrees. So 3y plus y is 4y plus 20 equals 180, because we add them together and set it equal to 180 because they're supplementary. Subtract 20 from both sides, 4y equals 160, divide by 4 on both sides, y equals 40. Okay? So now all we have to do is plug it in. So 40 plus 20 is 60. Okay? So if this angle is 60 and both of these angles are supplementary, what should the measure of this angle be? 120. Because 120 plus 60 gives you 180. These are same side interior angles, and same side angles, whether they're interior or exterior, same side interior angles are supplementary. Okay? So that is our algebra connection for lines and angles.